Hello everyone, how are you all? I hope all of you are doing great. So since your board exams are going to start from 17th of February, so we have started a revision series for all of you and one maths class has already completed in this revision series, and this is the second math session, and in this session we are going to learn about polynomials, right? So we will start from the basic, like what is constant, variables, algebraic expressions. So everything we will see in this class. And let me introduce myself. My name is Neha and I have done my post graduation from IIT Gandhinagar. So now let's start the class. So first let's start from the constants, that what are constants and variables, right? So we know that, let's suppose if I will give you this equation, that is x plus 4 equal to 5, right? So in this equation, what is the value of x we will get from this equation? The value of x is 1, right? Okay. Now if I will give you some another equation, let's suppose if I am giving you this equation, x plus 6 equal to 7 or x plus 6 equal to 9. So from here, what is the value of x we will get? The value of x we will get, it is x equal to 3, right? So we have seen that we have two equations, right? X plus 4 equal to 5 and x plus 6 equal to 9, correct? So here the value of x, it is not fixed here, right? The moment I have changed my constants in my equation, the value of x, it is also changed with the equation, right? So here we can see that the value of this x, it is not fixed here, right? The value of x is not fixed. So what is this x? This x, we call it, it is a variable. Why it is a variable? Because its value is varying with the equations, right? So this is variable. Now what is constant? Whose value is always fixed. So any number, if you say any real numbers, 1, 2, 3, any natural numbers, any fractions, and if you will see decimals, all of these are constants. And what are variables? So generally we denote variable with small alphabets, that is x, y, z, p and q. These are generally we denote our variables with these alphabets. So what are constant? Constant whose value is always fixed. And what are variables? Whose value is not fixed. It depends on the equation that what can be the value of the variable, right? Now we will see that what is an algebraic expression. So an algebraic expression is an expression in which you combine your constant and variables by using the signs plus, minus, multiplication and division, right? For example, give me some variable. Okay, let's take variable 4y, right? So we have variable 4y. Then let's take a constant 5 and let's take a constant 9, right? So we have variable 4y here, variable 5, constant 5 and 9 here, okay? Now if I will combine my variable and constant by using the signs plus and multiplication, okay, I can use any sign here, I can combine by using any sign. So now this is an expression, okay, and we call it as algebraic expression. So what is algebraic expression? It is very simple, in which you combine your constant and variables by using these signs, okay? So anything, let's suppose if I am taking this x square plus 9 divided by y plus 4. So this is also an algebraic expression, right? So this was also very easy. What is an algebraic expression? Okay. Now we will see that what is a polynomial. So basically a polynomial is a special type of algebraic expression in which the power of variables can only be whole numbers, right? For example, if I give you this expression, let's suppose we have x square plus x raised to power minus 1 plus x raised to power 2 by 3, okay? So here what are the power of variables? So here the power of variable is 2, here it is minus 1, here it is 2 by 3, right? So here the power of variables, they are negative also and they are fractional also, correct? But in like polynomials, the power of variables are only whole numbers. So the power of variable can be 0, it can be 1, it can be 2, so it can be any whole number. So except whole number can like any other number cannot be power of your variable in the polynomials. Okay. So this x square plus x raised to power minus 1 plus x raised to power 2 by 3, it is an expression, but it is not a polynomial. Why it is not a polynomial? Because here the power of x is minus 1 also and 2 by 3 also. Okay. So I hope this polynomial is clear to all of you. So what are the conditions for any algebraic expression to be a polynomial? So the condition is that the exponent should be a non-negative integer. That is, a exponent should be a whole number. It starts from 0, so 0, 1, 2 and so on. This is the only allowed powers for your variables. And the exponent should not be in the denominator, right? For example, if I will give you this algebraic expression, that is x square plus 1 upon x, right? So in this algebraic expression, this x is in the denominator, right? So this is not a polynomial, because for polynomial the exponent should not be in the denominator. And what is the third condition? That your coefficient should be a real number. So whatever your coefficients are, an minus 1, so that should always be a real number. Okay. Now, what is a general notation for a polynomial? How we like represent our polynomials? So this is generally we write our polynomials, that is an x raised to power n plus an minus 1 x raised to power n minus 1 plus and so on up to n on. So here this an minus 1, an minus 2, these are the coefficients. Okay. This n minus 1, they are the power of the variables, and again the power are only whole numbers. Okay. So this was about the polynomials, and these are the three conditions for an algebraic expression to become a polynomial. Okay. So I hope this is clear to all of you. Now we will see one question. So here we have some algebraic expressions. So we need to classify that which one is algebraic expression and which one is polynomial. Okay. So let's start with the first algebraic expression. So we have x raised to power 5 by 2 divided by x raised to power 3 by 2. Okay. So if you will look at here, okay, so here what are the powers of x? The powers of x is in fraction, right? Fractional power of x. So here you will say that this is not a polynomial, because in polynomial the power of the variable is not fraction, correct? But if you will simplify this, so after simplification what you will get? So x raised to power 5 by 2 minus 3 by 2, right? And then after this you will get x raised to power 2 by 2, that is x raised to power 1, correct? So now here what is the power of x? The power of x is 1, which is a whole number. So this is a polynomial. Okay. So whenever you have an algebraic expression, your first task is to simplify that algebraic expression, and then after that check that what is the power of your variable. Got it? Now let's see the second algebraic expression, that is we have x square plus 1 upon x. So in x square plus 1 upon x, here this variable is in the denominator, right? This is in the denominator. So and what was the condition for a polynomial, for an algebraic expression to become a polynomial? That your variable should not be in the denominator, right? जो variable है वो denominator में नहीं होना चाहिए. So this is also not a polynomial. Got it? Now let's see this third algebraic expression, that is we have under root x raised to power 6 plus x raised to power 4. So here if we will see, so it is under root x raised to power 6, right? So we know that under root means we have a half power, whatever, if we have under root x. So it means that we are taking half power of x, correct? X raised to power half. So here under root x raised to power 6. So first again we will simplify it, okay? So after simplification we will get x raised to power 6 and its power is half. So it is nothing but x cube, right? So under root x raised to power 6 means x cube, and you have plus x raised to power 4, right? So here what are the power of variables? It is a whole number 3 and 4. So this is a polynomial, right? Similarly this fourth one also. So you have to again simplify it. Whatever algebraic expression you have, you need to first simplify it and then see what is the power of the variable. Okay. So here also if we will simplify, we will get x cube plus 1 by x and then we will multiply with x. Now you can cancel the x here. So you will get x cube plus 1, right? So again here the power of x is a whole number. So this is a polynomial. So when you simplify this fifth one also, you will get x plus x square here, because what is under root x into under root x? Under root x into under root x, it will give you x here. So after simplification, this fifth one, you will get x plus x square. So this is also a polynomial, right? Okay, now let's see this last one. So in last one, you have under root 7x square minus 2 upon 3x plus 5, right? So here you can say that here we have this under root 7, right? But half power of fractional power, it is not allowed in the polynomial. So maybe this is not a polynomial, right? But no, this is a polynomial. Why? Because the power is, the whole power is allowed on the variables, okay? There is no constraint on the coefficient of the variable. The coefficient of the variable can be irrational also. It can be fraction also, okay? And here the coefficient is irrational. The power of x is 2, the power of x is 1. So it is a polynomial, okay? So I hope this is clear to everyone. Now let's see that what is degree of a polynomial, okay? So let's see one example of this. So let's suppose I have a polynomial px equal to 2x raised to power 6 plus x raised to power 5 plus under root 2 x raised to power 4. Okay, let's suppose I have this polynomial. Now here, what are the power of the variables? So what are the powers? So here the power is 6, here the power is 5 and here the power is 4, right? So in 4, 5 and 6, what is the highest power here? If I will ask you, all of you can write in the message that what is the highest power of this variable? Everyone please, what is highest power here? So 6 is the highest power, right? So what is degree of this polynomial? The degree of this polynomial is also 6, okay? So what is degree of any polynomial? It is the highest power of the variable. In your polynomial, whatever is the highest power, that will be degree of your polynomial, right? I think it is also clear to everyone, right? Now let's see some questions on degree of a polynomial. So we have this polynomial, that is under root 7 x cube plus root 5 x square plus 3 upon 4, right? So here, what is the powers of variables? So the power of variable is 3, the power of variable is 2, right? Now from 3 and 2, what is the highest power? The highest power is 3. So what is degree of this polynomial? Degree of this polynomial is also 3, okay? Now we have this polynomial x raised to power 5 upon 2 upon x raised to power 3 by 2, okay? So again, first we will simplify this algebraic expression. So we will get x raised to power 5 by 2 minus 3 by 2. That is x raised to power 2 by 2, that is x raised to power 1. So what is its degree? So here we have only one term, right? And its degree is 1 because the power of the variable is also 1 here, okay? Now we have this algebraic expression, that is x plus 2 whole square equal to x square plus 5, right? Okay. So now maybe some of you will look at this polynomial and say that, okay, the degree of this polynomial is 2, right? But no, its degree is not 2. Why this is not 2? Because if you will simplify this, okay, let's simplify this. So what is x plus 2 whole square? So it will be x square plus 4 plus 4x, right? Then again you have equal to x square plus 5, correct? Now here this x square and x square, it will get cancelled out and you will get 4x minus 1 equal to 0, right? So initially if the power is in negative, then it should be, no, you will not raise whole numbers. So it starts from 0, 1, 2 and so on, okay? So no negative power is allowed for the variables, okay? So here if you will simplify it, so now what is its degree? So now its degree is 1, right? Because only one variable is there and x raised to power 1, so its degree is 1. Got it, everyone? So again, always whatever polynomial you have, first simplify this, and after simplifying, see that what is the degree of your polynomial, what is the highest power. Okay, now let's see types of polynomials. So types of polynomials we have based on number of terms, okay, and we have based on degree. So based on number of terms, we have three types of polynomials. So first we have monomial, in which you have only one term in your polynomial. So for example, if you have x square, y, or x, 2x, okay. So all of these are example of monomials because you have only one term here, right? Now what is binomial? In which you have only two terms in your polynomials, right? For example, you can take x plus 2 or 4x plus 5. So all of these are binomial because they have only two terms. Now what is trinomial? In which you have three terms. So you can take any trinomial like for example x square plus 4x plus 2, right? So in this we have only three terms, x square, 4x and 2. So this is a trinomial, right? So on basis of number of terms, we have three types of polynomials, that is monomial, binomial and trinomial. Okay. Now we will see that based on degree, what are the types of polynomials we have. So first we have a polynomial of degree 0, okay. So if your polynomial is a non-zero constant, okay, non-zero constant, why I am saying? Because the zero, if we take our polynomial as 0 only, okay, so its degree is not defined. The degree of 0 polynomial is not defined. So that's why if you are taking a polynomial, okay, which is a non-zero number, non-zero constant, let's suppose if you are taking your polynomial as 5 and polynomial as 6, okay, so this is a constant polynomial and we say that its degree is 0. Why its degree is 0? Because any non-constant polynomial, let's suppose if I have this polynomial px equal to 5, I can write this 5 as 5 into 1, that is 5 into x raised to power 0, right? Now here, what is the power of 0? What is the power of variable x? It is 0, so its degree is also 0, okay? Now, what is a polynomial of degree 1? So, polynomial of degree 1, we call it as a linear polynomial, right? For example, if I will give you this polynomial 4x plus 5. So, here, what is the degree of this polynomial? It is 1. So, this is a linear polynomial, right? For example, if I will give you 5x plus 3, this is also a linear polynomial, okay? Now, what is quadratic polynomial? So, a polynomial of degree 2, we call it as quadratic. Then a polynomial of degree 3, we have cubic polynomial, and a polynomial of degree 4, it is biquadratic polynomial, okay? So, this was the types of polynomials depending on the what is degree of your polynomial, okay? Now, we will see that what is value of a polynomial, right? So, for example, let's suppose you have a polynomial px equal to, right, 2x square plus 4, okay? Let's suppose you have this polynomial. So, now if I ask you that what is value of this polynomial at x equal to 2, so it means that if I will substitute in the place of x, if I will write 2 here, then what is its value, right? So what will you do? Just substitute in place of x 2. So you will get 2 into 2 square. So this will be 8, 8 plus 4, and this will be 12, right? So here this 12 is the value of this polynomial. So it is very simple. Whatever polynomial is given to you, in place of that, substitute the value of your variable. You will get the value of that polynomial, okay? Now, why we are discussing this? Because let's suppose if I will give you this polynomial px equal to x square minus 4, okay? Let's suppose I am giving you this polynomial. So here if I will ask you that in place of x, let's suppose in place of x if I am writing 2 here, okay? Then what is the value of this polynomial for x equal to 2? So it is 2 square minus 4, that is 4 minus 4 equal to 0, right? So at x equal to 2, my value of polynomial is 0, okay? Now tell me that what is its value when I will substitute x equal to 3, okay? So now let's substitute x equal to 3 here. So P3 equal to, you will get 3 square minus 4, that is 9 minus 4, and it is 5, right? Okay. So what you have observed here, that when I have substituted x equal to 2, the value of my polynomial is 0, right? And when I have substituted x equal to 3, the value of my polynomial is 5. It means that there are some particular values of my variable at which the value of my polynomial is 0, right? So we call that as zeros and roots of our polynomial, right? So what is 0 or root of a polynomial? The value of a variable at which the value of your polynomial is 0, okay? For example, if I will give you this polynomial px equal to, let's suppose, x square minus 9, right? So here, what are the zeros of this polynomial? So if we will substitute x equal to minus 3 here in this equation, so what we will get? P of minus 3 equal to, it is minus 3 square minus 9, that is 9 minus 9, and it is 0, right? So what is this minus 3? It is 0 of this polynomial. Got it? Okay. So I think this is clear to everyone, what is zeros and roots of a polynomial, right? Okay. Now let's move ahead and let's do a question on zeros of a polynomial. So here you have this cubic polynomial px equal to 3x cube minus 5x square minus 11x minus 3, right? Okay. Now one by one, let's check that 3, minus 1 and minus 1 upon 3. These are the zeros of this polynomial or not, okay? So let's check for 3 first. So we will get p of 3 equal to 3 of 3 cube, right? Then minus 5, 3 square, then minus 11 into 3 and minus 3, okay? After this, what we will get? So it is 3 into 27, that is 81. So, and it is 9 into 5, that is 45, minus 33, minus 3. After adding this, you will get, if you will add 45, 33 and 3, you will get minus 81, right? So this is a zero of this polynomial, right? Now I want to all of you that try for minus 1 and minus 3, minus 1 by 3, that this is zero of this polynomial or not, okay? So try for this and write that you are getting this as zeros of your polynomial or not, okay? Now let's see that what is geometric meaning of zeros of a polynomial, right? So for example, that you are not able to compute the zero of your polynomial. We will see different methods that how to compute zero of a polynomial. But let's suppose if for some polynomial you are not able to compute the zero of that polynomial, right? So in that case, how will you find that how many zeros your polynomial have? Okay, so you can find the zeros. You can find the zeros by looking at the graph of your polynomial, okay? So let's suppose you have a polynomial and the graph of that polynomial looks like this, right? Okay. Now if I ask you that this polynomial has how many zeros, right? So how many zeros it has? So just to see that what is its intersection with the x-axis, okay? So with the x-axis, see what are the points it is intersecting. So see, this is the one point, right? And this is the another point. So how many zeros it has? It has 2 zeros, okay? Got it? So what are like zeros of your polynomial? It intersects your x-axis at one point, okay? If let's suppose I have a quadratic polynomial or I have any polynomial and the graph of that polynomial looks like this, okay? Graph of that polynomial looks like this. Then how many zeros it has? So just see that what is its graph of this polynomial, how it is intersecting with the x-axis. So this is the one point, right, where it is intersecting with x-axis. This is another point, second point, and this is the third point. So it has how many zeros? It has 3 zeros, right? Got it everyone? This geometrical meaning. So by looking at the graph only, you can tell that how many zeros or roots of your polynomial has, right? Okay. Now here I have some graphs of polynomials. So you can write in chat box that what are the zeros of these polynomials. So first I have this graph of a polynomial, right? So here if you will look at the graph, so how many zeros it has? So it is intersecting the x-axis only at one point, right? Only at one point. So how many zero it has? It has only 1 0, right? Okay. After this, I have this graph. So again, this is intersecting the x-axis at how many points? So it is intersecting at 3 points. So how many zeros it has? It has only 3 zeros, right? Then similarly, I have this graph and it is intersecting the x-axis only at 2 points. So it has 2 zeros, right? So in exam also, if they will ask you that by looking at the graph, tell that how many zeros or roots of that polynomial has. So what will you do? You will just see its intersection point with the x-axis. If it has one intersection point, it means it has 1 zeros. If it has 2 intersection point, it has 2 zeros. Okay. So I hope this is clear to everyone. Now let's see that nature of roots of a quadratic equation. Okay, so let's discuss about quadratic equations now. So what are quadratic equation or quadratic polynomial? It looks like this: ax square plus bx plus c equal to 0. Okay, this is general form of any quadratic equation. Got it? Where the condition is that a should not be 0, because if a is 0, then you will get only bx plus c. So it will be a linear equation, not quadratic, right? Now here, for the quadratic equation, it has maximum 2 roots, okay? Because we know that whatever is the degree of our polynomial, it can have maximum that number of roots, right? So here it is ax square plus bx plus c. So its degree is 2, okay? So maximum it can have 2 roots. So it can have 0 root, 1 root, it can have 2 roots, but it cannot have more than 2 roots, okay? So this is the one thing. Now second is that what are the nature of the roots, okay? So nature of roots means that whether the roots are real, the roots are equal, the roots are unequal or imaginary, that are the nature of roots, right? So for the quadratic equation, how we find the nature of roots? So we look at the discriminant of the quadratic equation. Okay. Now if we have a quadratic equation, let's suppose ax square plus bx plus c equal to 0, right? So what is its discriminant? So b square minus 4ac, it is the discriminant of this quadratic equation. Okay. And generally we denote our discriminant as d. So if we have this quadratic equation, then its discriminant is b square minus 4ac. This is the discriminant, okay? Now, why the discriminant is important? Because we find the nature of roots of any quadratic equation by looking at the discriminant, that what is its discriminant, right? Okay. Now let's see that if your quadratic equation has discriminant 0, okay, in that case, your quadratic equation has real and equal roots, okay? So it has 2 roots, both the roots are real and both the roots are equal. And what is that root? So it is equal to minus b upon a. So this is the root of your quadratic equation when d equal to 0, okay? Got it everyone? Now after this, what are the graph? How a graph of quadratic equation looks like? Okay, when d equal to you have 0. So when the value of your a, it is positive, then it looks like an upper parabola, right? And when it is negative, it looks like a lower parabola. That is, it is downwards. So this is how a graph of quadratic equation looks like when your discriminant is 0, right? Now we will see that when our discriminant is less than 0, in that case how the graph looks like and what are the nature of roots. So if your discriminant is less than 0, in that case the roots are imaginary, right? So when your quadratic equation has discriminant less than 0, so in that case your roots are not real, roots are imaginary. For example, if I will give you this equation, x square plus x plus 1 equal to 0, okay? We have this quadratic equation. So now here, what is the value of d? So what was d? It is b square minus 4ac, right? Here, what is the value of b? The value of a is also 1, b is also 1 and c is also 1, okay? Now let's substitute here. So it will be 1 square minus 4, that is 1 minus 4, and its value is minus 3, right? So here the value of discriminant is less than 0, okay? So it's like what are the roots? So it has only imaginary roots, okay? It don't have any real roots, right? So I hope this is clear. And how the graph looks like? So when a is greater than 0, so since it has no roots, okay, so it will not intersect with the x-axis, right? So that's why its graph is, when a is greater than 0, then its graph is above the x-axis, and when a is less than 0, its graph is below the x-axis, okay? So, okay, I hope this is clear to everyone. Now let's see that when the discriminant is positive, then what are the nature of roots? So in case of positive, your roots are real and both the roots are unequal, okay? So in that case, your roots are not equal, okay? For example, if I will give you this quadratic equation, that is 4x square plus x plus 1, right? So in that case, or you can take 2x square, x square plus 2x plus 1. Okay, let's take this quadratic equation. Now here, what is the value of d? So what the value of d you will get here? So it is b square minus 4ac, right? That is 4 minus 4. Okay, so here the value of d is 0, so it means it has equal roots, right? Okay, so when the value of d is greater than 0, in that case you will get unequal roots, okay? And how the graph of your equation looks like in that case? So you will get a graph in which it is intersecting your x-axis at 2 points, right? Because it has 2 unequal roots, so it will intersect your x-axis at 2 different points, okay? So this was the nature of roots of your quadratic equation when you know the discriminant, okay? Now let's see that if you, let's suppose if you have a quadratic equation, right? So how will you find the zeros of your quadratic equation or roots of your quadratic equation, right? So we have different methods for that. So first we have factorization method. So what is the factorization method? In this, what you do, whatever quadratic equation you have, right? First you will convert your equation in this form, that is ax square plus bx plus c, okay? Your first task is you will convert your equation in this form, right? After this, you will multiply the coefficient of x square and the coefficient of c, right? You will see that what are the factors, got it? And then you will simplify it, right? So let's see an example for this, for factorization method. Let's suppose you have this quadratic equation, that is 3x square plus 5x equal to 2, okay? So what was the first task? To convert our quadratic equation in this form, that is ax square plus bx plus c equal to 0. So after converting this, what will you get? 3x square plus 5x minus 2 equal to 0, right? Okay. Now after this, what we will do? We will do factorization here. So first we multiply 3 into 2. So 3 into minus 2, we will get minus 6. Now we will try to find the numbers, okay, such that if we will add those two numbers, we will get the middle term, that is 5, and if we will multiply the numbers, we will get this product AC, that is minus 6. Now what are those numbers? So we know that if we take x equal to 6 and y equal to minus 1, right? So then its addition is 5 and multiplication is minus 6. So now you can substitute here. So you will get 3x square, right? This 5 you can write it like this, it is 6x minus 2 equal to 0. Now just factorize it. So here you can take 3x common and it is x plus 2. Here you can take minus 1 common, x plus 2 equal to 0. And from here the value of, so you will get 3x minus 1 and x plus 2 equal to 0. And from here the value of x you will get 1 by 3 and minus 2. So they are the zeros of this polynomial. Got it? So this is the factorization method. Okay. Now we will see that what is square root method to solve or to find the zeros of your polynomial. Okay. So in square root method, what we do, we convert our equation in this form. So we try to convert our equation in this form, x plus a whole square equal to b. Okay, so let's suppose if I have this quadratic equation, x square plus 4 equal to 8, right? So from here, what is the value of x I will get? The value of it is x square equal to 8 minus 4, that is x square equal to 4, right? So I have converted my equation in this form, right, where the value of a is 0 here, correct? Now from here just take the square root of 4. So x equal to, you will get plus minus square root of 4. So the value of x you will get plus minus 2, right? So they have two roots, that is plus 2 and minus 2. Okay. Now let's see one more example of this square root method. So let's suppose if you have this quadratic equation 5x square plus 10x minus 3. So what is our first task? To convert our equation in this form, that is x plus a whole square equal to b, right? This is the first task. Now here you have this equation 5x square plus 10x minus 3. Okay. So if you have a quadratic equation in which the coefficient of the x square is not 1, so your first task is try to make it 1. Okay. So here how will you make it 1? So we want to find its roots, so that's why we have equated it is equal to 0. So divide equation with 5. So after division with 5, what will you get? X square plus 10 upon 5, that is 2x, minus 3 upon 5, it is equal to 0, right? Now from here, whatever is your, okay, now from here whatever is your coefficient of x, okay, divided by 2 and add and subtract the square of it. So here what is the b? B is 2, right? Then take b by 2, that is 1, and add the square and subtract the square. Okay. So here x square plus 2x, so add 1 minus 1 and then you have minus 3 by 5, it is equal to 2. Now if you will see, so this is, what is this? X square plus 2x plus 1. It is x plus 1 whole square, right? So here it is x plus 1 whole square minus 8 by 5 equal to 0. So you have x plus 1 whole square equal to, you will get 8 upon 5, and from here x plus 1 equal to, you will get, so you will take the square root now. So it is written 8 upon 5 and you will get root 8 upon root 5 and plus minus, whenever you take the square root, it comes with plus minus both the signs. Okay. So here it is x equal to, you will get minus 1 plus minus under root 8 upon under root 5. So this is the root of this equation. Okay. So I hope this is clear to everyone that how will you calculate the roots of your polynomial by using the square root method. Okay. So just try to convert whatever is your polynomial, just try to convert in this form x plus a whole square equal to b, and then take the square root. So x plus a equal to square root of b and x equal to, you will get minus a plus minus square root of b. So I just hope this is clear to everyone. Now let's see one more method, right? That is, so this is the easiest method to calculate the roots of your polynomial, right? So let's suppose you have a quadratic equation, that is ax square plus bx plus c equal to 0, right? And what is the condition? That a should not be 0. Got it? So what is the quadratic formula? So your roots are this. Okay. So this is the formula to calculate the roots of your quadratic equation, that is minus b plus minus under root b square minus 4ac upon 2a. Okay. So this is the formula. For example, if I ask you that, so here we have one quadratic equation, that is 5x square minus 2x minus 3 equal to 0, right? So if we compare this with the general quadratic equation, that is ax square plus bx plus c, right? So what is my value of a here? My value of a is 5, my value of b is minus 2, and my value of c is minus 3, right? These are the values of a, b and c. Now see that what are the values of x? So by using the formula, my roots are, it is minus b, that is minus of minus 2, okay, then plus minus under root of b square, so here it is minus 2 whole square, then minus 4, and the value of a is 5 and the value of c is minus 3, okay, and then divided by 2a, so 2 and the value of a is 5, right? So now just simplify it, so you will get 2 here, 2 plus minus under root of, so it is 4, and then you will get here 60, so it is 4 plus 60 and divided by it is 10, so you will get here 2 plus minus under root 64 upon 10. So now you can simplify it, 2 plus minus it is 8 upon 10. So after simplification you will get that what are the roots of your equation, okay. So from the three methods that we have seen, that is factorization method, square root method, and by using the quadratic formula, this is the easiest way to find the roots of your equation, okay. So this was about the roots of quadratic equation, right? Okay. Now we have some relation between the roots of quadratic equation as well, right? So let's suppose if you have this quadratic equation, y equal to ax square plus bx plus c, okay. So and we have assumed that the roots of this quadratic equation is alpha and beta, okay. They are the roots of this quadratic equation. Then the sum of roots is always equal to minus b upon a, and the product of roots is always equal to c upon a, okay. So this is very important because in board exams there are so many questions which they asked from this formula. So this formula is very important. Now for similarly we have relation between roots of cubic polynomial as well, okay. So let's suppose if you have this cubic polynomial y equal to x cube plus bx square plus cx plus d, right? Then what are some of the roots of the polynomial, this cubic polynomial? That is alpha plus beta plus gamma is equal to minus b upon a, and the product of the roots, if you are taking product of two roots and you are taking the sum of that, so it is equal to minus c upon a, and the product of root it is equal to minus d upon a, okay. So these are some important relation related to the roots of a cubic polynomial, okay. So I hope this is clear to everyone. So now we are going to start the previous year questions. So this was the concepts that we have learned in this chapter. So now let's start with the question part, okay. So here we have the first question, that is if x upon 12 minus 3 upon x equal to 0, then what is the value of x, okay. So here to simplify this question, okay, so I am repeating it again. Here you have a cubic polynomial, right? So what are the roots of these polynomials? So we have assumed that the roots of polynomial is alpha, beta and gamma, right? So these are some important relation in between the roots of this polynomial, okay. That is, if you will take the sum of roots, it is always equal to minus b upon a. If you are taking product of two roots and you are taking their sum, then it is equal to c upon a. And if you are taking product of roots, so it is always equal to minus d upon a, okay. So these are some simple and very important formula in this chapter. Now we are starting the previous year questions, right? So here we have this equation, that is x minus x upon 12 minus 3 upon x equal to 0, right? So here what is the value of x? Got it? So okay, so first let's simplify. So you can use any method here. You can use the factorization method, square root method and formula method as well. So let's simplify this equation. So after simplification, so in denominator you will get 12x. Here you have x square minus 36 equal to, you will get 0, right? So from here you will get x square minus 36 equal to 0. So the value of x square is 36, and from here the value of x, it is plus minus 6, right? So here I have used the square root method. So just simplify it and you will get the value of x, it is plus minus 6. So it has two roots, okay. So I hope this question is clear to everyone because this was very simple. Now let's see this question, okay, that which of the following quadratic equations has real and equal roots, right? So here in this question, you can do this question by using two methods. First, let's check the discriminant of each of the quadratic equation. If the discriminant is 0, then we know that our quadratic equation has real and equal roots, right? Okay. Or you can simplify the equation and you can get the value of the variable. So let's simplify this first equation. So what is here? It is x plus 1 whole square. So by this method you will do by this method. I am simplifying it and I am getting what is the value of x. So it is x plus 1 whole square equal to, you have 2x plus 1. Okay, so just simplify it. So you will get x square plus 1 plus 2x equal to, you have 2x plus 1. Now you can cancel this 1 with 1, 2x with 2x, you will get x square equal to 0. And the value of x you have 0 and 0, right? Because the degree of its polynomial is 2. Okay, we will see this type of question as well. Okay, don't worry. So we have x square equal to 0 and the value of x we will get 0 and 0, right? So it has two real roots and both the roots are equal as well. Okay, so this option is correct. Okay, now let's see other options also. So we have here x square plus x equal to 0. So simplify it. So after simplifying, let's take x common. You will get x plus 1 equal to 0, right? From here you will get x equal to 0 and minus 1. So it has two unequal roots. Okay, now let's see the third equation. So we have x square minus 4 equal to 0. From here the value of x we have, it is plus minus 2, right? So it has also real and unequal roots, right? It is plus minus 2. Okay, and then we have x square plus x plus 1 equal to 0. So for this, x square plus x plus 1 equal to 0. If you are not able to simplify the equation, what do? Just see that what is the value of discriminant here. So if you will see what is the value of discriminant, so it is b square minus 4ac. So for this equation, what is the value of b? The value of b is 1, right? So it will be 1 square minus 4ac. So it is 1 minus 4, that is minus 3. Okay. So here the value of this discriminant is less than 0. So that's why it has imaginary roots, right? So this is also not the correct options. Okay. So I hope this question is clear to everyone. So whenever in exam they will ask you to find that check that these equations has real and equal roots or not. So in that case, just check that what is the discriminant of the equation. If the discriminant is 0, it means that the equation has real and equal roots. Okay. Now let's see another question. So here we have find the value of k. Okay. So that the quadratic equation 4x square plus kx plus 1 equal to 0 has real and equal roots. Okay. So here also what is the condition? That the quadratic equation has real and equal roots. So what we will do? We will substitute the discriminant equal to 0, right? So what is the discriminant here? So discriminant, it is b square minus 4ac equal to 0. That is, so for this equation, it is k square minus 4. The value of a is 4, the value of c is 1. It is equal to 0. So k square equal to, you will get 16. And the value of k, you have plus minus 4. Okay. So here we have two values of k, that is plus minus 4. So for these values of k, it has real and equal roots, right? So I hope this question is also clear to everyone. Now let's move to the next question. So here what is the question? That the denominator of a fraction, right? The denominator of a fraction is 1 more than twice the numerator, right? So and on what in the question what is asked to you, that find the fraction, right? So whatever they have asked you in the question to compute, right, always assume that. So here they have asked you what is the fraction or find the fraction. So assume that the fraction is x upon y. Okay, where x is the numerator and y is the denominator. Okay, now what is given to you in the question? That your denominator is, okay, it is twice of your numerator and more than 1. So twice of your numerator, so you will multiply 2 in your numerator, and it is more than 1. Okay, so this y equal to, you have 2x plus 1. So this is the first equation you are getting from here, right? Now after this, what is given to you? that the sum of the fraction and its reciprocal is 2 and 16 upon 21. So what is fraction we have? Fraction is x upon y. What is its reciprocal? It is y upon x, and it is given to you, it is 216 upon 21, right? Now just simplify it. After simplification, what you will get? So it is xy here, and here it is x square plus y square equal to, you will get 58 upon 21. So after simplifying, you will get here 58 and it is 21. Now what is the value of y? The value of y is 2x plus 1. Now let's substitute here. So you will get x square plus, it is 2x plus 1 whole square, and it is divided by x, 2x plus 1. It is equal to, you have 58 upon 21, right? Now after simplification, what will you get here? So it is x square. So here you will get x square and 2x plus 1 whole square, right? So it is 4x square plus 1 plus 4x, and here you have x into 2x plus 1, that is 2x square plus x, right? This you will get in denominator, and it is equal to, you have 58 upon 21. Okay, now just simplify it. So what will you get? Here you have 21x square plus, it is 84x square plus 21 plus, again you will get 84x here, and here you will get, so it is 116x square plus 58x. Okay, now just simplify it. So after simplifying, what will you get? So it is 116x square, right? Okay, here you have 5x. Okay, you will add this. So first add this. So you will get here 105x square, because you have 21x square and 84x square, right? So first add this. Then you have 21 plus 84x equal to, you will get 116x square plus 58x. Now just simplify it, and so it is 116x square minus 105x square, right? Then plus 58x minus 84x, and you will get minus 21 equal to, you have 0. Okay, so after subtracting it, what you will get? So here it is 1, it is also 1. So it is 11x square minus, here you will get 6 and 2, minus 26x, and here you will get minus 21 equal to 0. Now after simplifying it, you will get 33 and 7. It is, so after, when you will simplify it, here it is 11x square. So this will be minus 33x plus 7x minus 21 equal to 0. So after simplifying it, you will get x. So you will take 11x common from here, and here it is x minus 3 plus 7 you can take common, it is x minus 3. So you will get x equal to 3 and x equal to minus 7 upon 11. Okay, so these are the roots of your equation. Okay, so this simplification you can do, but what was important in this question? To frame that what is the relation between your numerator and denominator, right? And how you are getting the quadratic equation, that is very important. Okay. Okay, so I hope this question is clear to everyone. Now let's move to the next question. So here what is given to you? If the sum of roots of the quadratic equation, okay, so you have this quadratic equation, ky square minus 11y plus k minus 23 equal to 0, right? Okay, so what is given to you? If the sum of the root of quadratic equation is 13 upon 21 more than the product of the roots, okay, then what is the value of k? So first let's assume that roots are alpha and beta. Okay, so roots are alpha and beta. So what is given to you? That product of roots, that sum of roots. So here what are the sum of root? It is alpha plus beta, right? Sum of root is 13 upon 21 more than the product of roots. Okay, whatever is the product of root, in this if you will add 13 upon 21, you will get the sum of roots, correct? Now from the equation we know that what is sum of roots, alpha plus beta, it is minus b upon a, right? So from equation what is the value of b? Minus 11, right? So substitute here, so you will get 11 upon k, that is the sum of roots. Now what is product of roots here? Product of root is c upon a, so this will be k minus 23 upon k, okay? Now just simplify it, so it is 11 upon k equal to, you have 13 upon 21 plus k minus 23 upon k, right? So from here, if we will multiply this k, so it is 11 equal to k, and here you have 13 upon 21 plus k minus 3 upon k, right? This you will get from this equation, yes. After this, what will you do? Just multiply with k. So 11 equal to, you will get 13k upon 21 plus k minus 3. So here you will get 11, okay, plus k minus 3, yes. Then you will get 11 plus 3 equal to, you have 13k upon 21 plus k, right? Then from here, this is, so you can take the LCM here, it is 1. So you will get 14 equal to, you have 13k plus 21k upon 21. So from here you will get 14 into 21 equal to, you have 34, right? And it is equal to, you have k. So and the value of k you will get 14 into 21 upon 34, right? So from here you can simplify it and you will get that what is the value of k. Got it? So in this equation, what was the important? That whatever relation is given to you, just simplify the relation and you will get what is the value of k. Okay. So I hope this question is clear to everyone, right? Now let's see that what is the next question. So here the next question is, you have this quadratic equation 1 plus a square x square plus 2abx plus b square minus c square equal to 0. Okay. And it has only one root, right? Then what is the value of c square into 1 plus a square? Okay. So when we have one root in a quadratic equation, what was the condition for that? That your value of the discriminant, it should be 0, right? If the value of discriminant is 0, we have one real and equal roots. So what is discriminant of this equation? So it is b square minus 4ac. So what is b here? 2ab, right? So the discriminant will be, it is 2ab, its whole square, then minus 4. What is a we have? 1 plus a square, and what is c we have? B square minus c square, it is equal to 0, right? So from here, what will be the value of 2ab whole square? It is 4a square, b square minus 4. Now you can multiply it. So it is b square plus a square b square, then minus c square minus a square c square equal to 0. Now you can simplify it. So you have 4a square b square. Now just multiply with the minus 4. You will get minus 4b square minus 4a square b square, right? Then plus 4c square and plus 4a square c square equal to 0. So from here this will cancel out, right? And 4 you can take common from here. So you will get, okay, so from here you will get minus b square plus c square plus a square c square equal to 0. And from here the value of c square, 1 plus a square, you will get, it is b square. Okay. So the answer of this question is b square. So this was also very easy. Whenever in the question you will see that they require real and equal roots or one root, in that case always substitute your discriminant equal to 0, right? And from there you are able to find the solution. Okay. So I hope this question is also clear to everyone. Now let's see that what is the next question. So this type of question they ask, I think in every year they ask this type of question. So this is very important type of question. So here what is given to you, that a train covers a distance of 480 km at a uniform speed, right? So what is distance given to you? Distance is given to you, it is 480 km. Okay. Now, if the speed of a train had been 8 km per hour less, right, it would have taken 3 hours more to cover the same distance. Okay, to cover the same distance, the time is now 3 hours less. So find the original speed of the train. That what is the original speed of the train? So let's assume that the original speed of the train, it is x. Okay, so original speed of the train is x, and let's assume that the then what is the new speed of the train? The new speed of the train will be, it is 8 hours less now, right? So the new speed is, we have x minus 8. Okay, now let's suppose that, okay, now what is the original time we have? If the speed is x, then what is the original time? So time equal to, we know it is distance upon speed, right? So original time we have, it is distance, that is 480 upon, okay, so time equal to, we have distance upon speed, right? So 480 upon, we have, what is the original speed? It is x. So original time is 480 upon x, right? Now what is the new time we have? The new time is, new is distance upon new speed, right? And distance, we have the same distance. For new time also we have the same distance, that is 480, that is 480 kilometer, right? So it is 480 divided by, now what is the new speed? It is x minus 8. Okay, so this is x minus 8. Now after this, what they are saying, that now the time is taken, it is 3 hours more to cover the same distance. Okay, so whatever is your original time, okay, whatever is your original time, from the original time, that is 480 upon x, in this, when you will add the 3 hours, right, because now the time, it is 3 hours more than the original time, right? So you will get this 480 upon x minus 8, right? Now you got this equation, right? So if you will solve this, you will get that what is your original speed, that is what is the value of x. Okay, understood everyone this question? So in this type of question, the framing of your quadratic equation, that is very important. So for that, what will you do? Just remember that what is your formula of speed, right? Now in that, whatever they are saying, just do according to that. For example, here they have said that the speed is 8 km per hour less. So in the speed, just subtract the 8, right? And then time is more, 3 hours more. So in the time, just add the 3, right? You will get your new time. Got it? So I hope this type of question now you are able to do in the exams, right? So after solving this, you can get that what is the original speed. Okay? Okay, now let's move to the next question. So here what is the question? That the zeros of a polynomial, so you have this polynomial x square plus px plus q, right? So the zero of this polynomial are twice the zeros of the polynomial 4x square minus 5x minus 6. So what is the value of p here? That is the question, right? Okay. So now we can assume here that the zero of this polynomial x square plus px plus q, that zero of this polynomial is, let's suppose, alpha 1 and beta 1. Okay, that is the zero of this polynomial. Now we have second polynomial, that is 4x square minus 5x minus 6, right? So let's suppose that its zeros are alpha 2 and beta 2, right? Okay. So from here, what is the value of alpha 2 plus beta 2? So alpha 2 plus beta 2, that is the sum of roots. You will get it is minus b upon a, that is 5 upon 4, right? Okay. Now they have asked you what is the value of p from here, right? Now for this equation, we have assumed that our roots are alpha 1 and beta 1, correct? So what is the alpha 1 plus beta 1 we have? The alpha 1 plus beta 1, it is minus b upon a, that is minus p, right? Okay, so we have two equations here. So let's suppose this is equation number 1 and this is equation number 2, right? Now something is given in the question. What is that? that the zero of this polynomial are twice the zeros of this polynomial, right? So we can assume that this alpha 1, because the zero of this polynomial is twice the zeros of another polynomial, so we can assume alpha 1 equal to twice of alpha 2 and beta 1 equal to, we have twice of beta 2, right? This we can assume. Now let's substitute these values here. So we will get twice of alpha 2 plus, in place of alpha 1 we can substitute twice of alpha 2 plus twice of beta 2 equal to, we have minus p. From here, what is the value of alpha 2 plus beta 2? So it is minus p upon 2, right? And what is alpha 2 plus beta 2 from the equation 1? It is 5 upon 4, right? So we have 5 upon 4 equal to minus p upon 2. Now from here you can cancel, and the value of p, you will get minus 5 upon 2, okay? So this is the value of p, right? So I hope this question is clear to everyone, right? So what we have done, we have just assumed the roots, and we have seen that what is the relation between the roots, and we have find the value of p. Okay, so now let's move to the next question. So here I have this question that the sum of zeros of a polynomial, right, px equal to 2x square minus k under root 2x plus 1, it is root 2, then what is the value of k, right? So just find the, what is the sum of roots here. So sum of roots will be alpha plus beta, it will be minus b upon a, right? So what is minus b here? B is minus k under root 2 and a is 2, right? So alpha plus beta equal to, we have k root 2 upon 2, and from, now this is given to us in the question. What is alpha plus beta? It is root 2. So root 2 equal to, we have k root 2 upon 2, right? Now root 2 and root 2 we can get cancelled. So the value of k we will get, it is 2. Okay, so this is the value of k. Understood everyone? So I hope this is also clear to everyone. This was very easy. The sum of zeros was given to you. So just apply that and you will get the value of k, it is 2. Now let's see another question. So we have, find the value of p, okay, for which this quadratic equation has two equal roots. So when we have two equal roots, when the value of the discriminant is 0, right, then we have two equal roots. So we have this equation px and x minus 2 plus 6 equal to 0. So from here just convert it into quadratic equation. So you will get px square minus 2px plus 6 equal to 0, right? So from here, what is the value of d we will get? So it is b square, that is 4p square minus 4ac, that is 24p equal to 0. So from here take 4p common, so you will get p minus 6 equal to 0. So the value of p you are getting 0 and 6, right? Okay. Now in this equation, if I will substitute this value p equal to 0, so what will I get? So after substituting p equal to 0, let's suppose in this equation, equation number 1, if I will substitute p equal to 0, I will get 6 equal to 0, right? But this is an impossible condition, 6 cannot be 0. So what is the value of p? The value of p is 6, okay? This is the value of p. So this question was also very easy, just like see what is the discriminant, substitute it is equal to 0 and you will get the value of your p, okay? So this was the question. Now let's see the another question. So we have a quadratic equation that is x square plus x minus 1, right? And we have assumed that alpha and beta are the zeros of this polynomial, okay? So from here, what is the value of alpha plus beta? The value of alpha plus beta will get, it is minus 1. And what is the value of alpha beta? It is c upon a, so it is also minus 1, right? So now what is the value of this? 1 upon alpha plus 1 upon beta. So just simplify it. So here you will get alpha beta. It is alpha plus beta here. Alpha plus beta is minus 1. Alpha beta is also minus 1. You can cancel and the value of it is 1, okay? So this was also very easy question. So I hope until this every question is clear to everyone. Now let's move to the next question. So here we have that find the quadratic polynomial, okay, whose zeros are 3 and minus 4. Okay, so always remember that if you have a quadratic equation, that is ax square plus bx plus c equal to 0, if you have this quadratic equation and the roots of the quadratic equation is alpha and beta, right? Then what is the quadratic equation whose roots are alpha and beta? So you can write it like this. It is x square minus alpha plus beta x plus alpha beta equal to 0. Okay, so if the roots of your quadratic equation is alpha and beta, then this is the quadratic equation you have. Okay, so now here what is given to you? That the roots of quadratic equation in this question, it is given to you alpha equal to you have 3 and beta equal to you have minus 4. So what is alpha plus beta? Alpha plus beta is minus 1, and what is alpha beta? It is minus 12. Okay, now substitute both in this equation. So you will get from here x square minus alpha plus beta, that is minus 1 x and minus 12. So your quadratic equation is x square plus x minus 12 equal to 0. Okay, so this is a quadratic equation whose roots are 3 and minus 4. Okay, so I hope this is clear to everyone, right? Now let's move to the next question. So here we have a question that find the value of p, okay, for which one root of the quadratic equation px square minus 14x plus 8 equal to 0, okay, it is 6 times the other. Okay, so let's suppose that the root of this quadratic equation is alpha and beta, right? Now in the question it is given to you that one root is 6 times the other roots. Okay, it is given to you in the question. Now let's substitute. Okay, so what is alpha plus beta here in this equation? What is alpha plus beta? Minus b upon a, right? So it will be 14 upon p, correct? Minus b upon a. Now what is alpha beta? Alpha beta is c upon a, that is 8 upon p. Okay, now in both the equation substitute this alpha equal to 6 beta. Got it? So in the first equation, if you will substitute alpha equal to 6 beta, so we will get here 6 beta plus beta equal to, we have 14 upon p, right? 7 beta equal to, we will get 14 upon p, that is 2 upon p. So the value of beta we are getting, it is 2 upon p, right? Now we can substitute this in this equation number 2. So from here we will get beta, okay, the value of beta is 2 upon p and the value of alpha is 6 beta. So first substitute the value of alpha here. So it will be 6 beta square equal to, you have 8 upon p, right? So we have this equation, that is 6 beta square equal to, it is 8 upon p. Now what is the value of beta here? It is 2 upon p, right? The value of beta is 2 upon p. So now just substitute here. So it is 6 and 2 upon p, that is 4 upon p square, it is equal to, you have 8 upon p. So from here 24 upon p square equal to, you will get 8 upon p, and this will cancel 3 times. Okay, now what is important here? That you can cancel this p with this p. Okay, now why you can cancel this p here? Because the value of p, it is not equal to 0. Okay, why the value of p is not equal to 0? Because here it is the coefficient of x square, right? And we know that in quadratic equation the coefficient of x square should not be 0. Okay, should not be 0, right? So here what is the value of p now? The value of p is 3. Okay, so you can cancel the value, you can cancel p from here, and this is the value of p, right? Yes, you can see the class. Okay, this is very basic class, and these questions are also very easy, don't worry. These are the PYQs, so you can see the class, don't worry. Okay, now let's see the next question. Okay, so here what is the question? That find the smallest value of p, right, for which the quadratic equation x square minus 2 p plus 1x plus p square equal to 0 has real roots, right? Okay, now when our quadratic equation has real roots, when the discriminant, the value of the discriminant is greater than 0, right? In that condition, the roots are real. Okay, so here just find what is the discriminant here. So it is b square, that is minus 2p plus 1 its whole square, right? Then minus 4ac, that is p square, and it is greater than 0. So now just simplify it. So you will get 4 here, then p plus 1 whole square, that is p square plus 1 plus 2p and minus 4p square. It is greater than 0. The condition is greater than 0. Now just multiply it. So you will get 4p square plus 4 plus 8p minus 4p square. It is greater than 0. Now you can cancel these things. So you will get 8p. Acha, now they have given only real roots. Okay, so it can be greater than or equal to 0 as well, right? Because in case of equal also we are getting the real roots. So it can equal as well here. So from here what will you get? 8p is greater than equal to minus 4, and the value of p, it is greater than equal to minus 1 upon 2, right? So what is the smallest value of p from here we are getting? The smallest value of p is, so what was the condition? That p is greater than equal to minus 1 upon 2, right? So from here what is the value of p? The value of p is minus 1 upon 2. Okay, so this is the smallest value of p for which our equation have equal roots, right? Sorry, real roots. Okay, not equal roots, real roots. Okay, now the question is that find the roots of the equation. Okay, for this value of p, what is the root of equation? So what is the equation we have? It is x square minus, and we have 2p plus 1x, so it is x square minus 2, here it is p plus 1x, and then we have plus p square equal to 0, right? Now just substitute the value of p, so you will get x square minus 2, this is minus 1 by 2 plus 1, that is 1 by 2x, and it is minus 1 by 2 whole square, right? So from here you will get that it is x plus x minus 1 by 2 and its whole square equal to, you have 0, and you will get that the value of x, it is 1 by 2 and 1 by 2. Okay, so for the smallest value of p, you are getting two real and equal roots, that is 1 by 2. Okay, so this was the question we have. So I hope this question is clear to everyone. So whenever they will ask you that for which value of p, for which value of k, the equation have equal roots, right? So for equal roots what will you do? You will substitute d equal to 0. For equation has real roots, for real roots what will you do? You will write this condition, that is d is greater than and equal to 0. Okay, so I hope this is clear to everyone. Now let's move to the next question. So here we have this question that find the least positive value of k, okay, for which this quadratic equation has rational roots, right? So what is the condition for rational roots? Okay, we know that for real roots what was the condition? That d should be greater than equal to 0, right? This is the condition for real roots. What is condition for rational root? That your d, it should be a perfect square. Okay, whatever is your discriminant, it should be perfect square. So perfect square means that it should be a square of some number. Got it? So now here for this quadratic equation, 2x square plus kx plus 4 equal to 0. What is the value of discriminant here? The value of discriminant is b square, that is k square, minus 4ac, that is 32, right? This is the value of discriminant. Now we will see that for which value of k, it is a perfect square. Okay, so if you will check that for k equal to 1, what is the value of d? It is 1 minus 32, that is minus 1, minus 31, it is not a perfect square, right? For k equal to 2 as well, you will not get a perfect square, right? So until k equal to 5, you will not get a perfect square here, right? Let's substitute k equal to 5 here in this discriminant. So d equal to, you will get 25 minus 32, right? So from here you will get minus 7. Okay, so here this is not a perfect square, right? Minus 7 is not a perfect square. Now let's substitute k equal to 6 here. So after substituting k equal to 6, what is the value of d you will get? It is 6 square minus 32, that is 36 minus 32, and it is 4, right? And we know that 4 is a perfect square, right? 4 equal to, we can write it is 2 square, correct? So for the value of k equal to 6, d is a perfect square and it has a rational roots, okay? So you can calculate the roots also for this value k equal to 6. You will get the rational root for this, okay? So whenever they are asking for the rational roots, try to make d as a perfect square. If your d is a perfect square, then your roots will be rational roots, okay? So I hope this question is also clear to everyone. Now let's move to the next question. So what question we have here? That the sum of two numbers. So we will only here try to compute the what is our quadratic equation. So we will only make the quadratic equation, and your task is to find the value of the variable, okay? So here what is given to you? That the sum of two number is 34. So let's suppose that two numbers are x and y. So sum is given to you, x plus y equal to, you have 34, right? So let's suppose this is your first equation. Now what is given to you? If 3 is subtracted from one number, so let's suppose from x, if I am subtracting 3, okay, and if 2 is added to another number, so if I will add 2 in my another number, so the product of these two numbers is 260, okay? So this is a product of these two number, that is 260. So let's suppose this is my equation number 2, right? Now what is the value of x from this, or the value of y? So the value of y we will get, it is 34 minus x, right? So substitute this value here. So here you are getting x minus 3. The value of y you are getting 34 minus x plus 2 equal to 260, right? So you will get here x minus 3, and here you have 36 minus x equal to, you have 260, okay? Now after simplifying this, you are able to find that what is the value of x, okay? So in this type of question, what is important? So this is your like the homework. Your task is to find the value of x here, or you can write in the chat box as well if you have find that what is the value of x, okay? So in this type of question, what is important? The important is that to frame that what is the equation they are saying, right? So whatever they are saying, just write the equation and then find the quadratic equation. You know different methods to solve the quadratic equation, right? So from there you can find that what is the value of x, okay? So I hope this question is also clear to everyone. Now let's move to the next question, and this is the last question of this class. So here you have this equation 4x square minus x minus 4, right? You have this quadratic equation, and it is given to you that alpha and beta, they are the roots of this quadratic equation, right? So find the quadratic polynomial whose roots are 1 upon 2 alpha and 1 upon 2 beta, right? Okay. So now what was that quadratic equation whose root is 1 upon 2 alpha and 1 upon 2 beta? So it will be x square minus 1 upon 2 alpha plus 1 upon 2 beta into x, and plus here you will multiply the roots, that is 1 upon 2 alpha into 1 upon 2 beta, right? This is the quadratic polynomial whose roots are 1 upon 2 alpha and 1 upon 2 beta, right? So now we just need to find that what is the value of these quantities, okay? We just need to find that. So what is 1 upon 2 alpha plus 1 upon 2 beta, right? So if you will simplify here, so take the LCM, you will get 2 alpha beta, right? And in the numerator, here you will get beta plus alpha, right? Now tell me, what is the value of alpha plus beta? What is value of alpha plus beta? So here alpha beta are roots of this quadratic equation 4x square minus x minus 4. So what is alpha plus beta? It is minus b upon a, that is 1 upon 4, right? And what is alpha beta? It is c upon a, that is minus 4 upon 4. that is minus 1. Okay, now let's substitute this value here. So beta plus alpha, it is 1 upon 4 upon, you have twice of alpha beta, it is minus 1. So the value of this is minus 1 upon 8. Okay, this is the value of 1 upon 2 alpha plus 1 upon 2 beta. Now what is this product? That is 1 upon 2 alpha and into 1 upon 2 beta. So this is 1 upon 4 alpha square beta square, right? Now what is 1 upon 4? So this is alpha beta whole square. What is the value of alpha beta? It is minus 1, right? So here you can substitute, it is 1 upon 4 minus 1 whole square, that is 1. So it is 1 upon 4, right? Now just substitute the value in the equation. So this will be x square minus 1 upon 2 alpha plus 1 upon 2 beta. This is minus 1 upon 8, right? So it is minus 1 upon 8x, and this product value is 1 by 4. So it is plus 1 by 4, it is equal to, you have 0. So now from here, what is the value of x you will get? Sorry, what is the quadratic equation you will get? So x square plus x upon 8 plus 1 by 4 equal to 0. Now you can simplify it. So it will be 8x square plus x plus 2 equal to 0. So what is the quadratic equation? 8x square plus x plus 2 equal to 0, right? So I hope this question is clear to everyone. So in this, the polynomial, the quadratic equation was given to you and the roots was also given to you. This is just find what are the sum of the roots, product of the roots, right? Then they have asked you what is the quadratic equation whose root is this, 1 upon 2 alpha, 1 upon 2 beta. So we have find what is sum of the roots, what is product of the roots, because we know that if we know the sum of root, product of root, we can find what is the quadratic equation, right? So we have find this, we have solved this, and we got that this is the quadratic equation we have. Okay, so this was the last question of this class. I hope this class was useful to you and this will help you in your board exams. So here this is the QR code. You can download the SISYA class app. Here we have classes from grade 1 to grade 10. So thank you so much for seeing the class. So if you like the class, then like, share and subscribe this YouTube channel. Thank you so much.